Okay, the next test on an alternator is check the voltage ripple using an oscilloscope. Okay, so again, this is the ripple effect of basically the top of each of the waves from a three-phase alternator. Okay, the ripples should be fairly uniform in size and shouldn't have an amplitude more than about a half a volt. Okay, so I've stated here 0.4 of a volt is the maximum size of the ripples from bottom to top. Okay, if we have a defective stator winding or defective diodes, then the alternator output will be reduced by about a third. Okay, so what you'll notice on the voltage ripple is you will have defects, and the defects might look something like this that you will see along the line. Okay, alright, that will increase the amplitude of the ripple and that will give you more ripple voltage. So in order to do this test, I've connected my oscilloscope. I could go across the battery, but you're probably better off going across the alternator. So I have my positive lead or red lead of my oscilloscope is connected to the battery positive of the alternator, and we're also connected to with the other lead of the oscilloscope, the black lead, negative lead, to the negative of the alternator. Okay, so our oscilloscope is set up. First of all, we're measuring AC. Okay, so even though our voltmeter is across the alternator at the moment, because it's AC, it's measuring 0. Okay, alright. And I'm measuring from 0 up to a half a volt, and from 0 down to a half a volt. Okay, alright, so plus half, minus a half. So we're basically looking for no more than a half a volt of voltage ripple. So when we measure from the top to the bottom, it shouldn't be greater than a half a volt. The timeline I'm using for this is from 0 right up to 20 milliseconds. It's 20 thousandths of a second to right across the screen from left to right. Okay, that's 5 times faster than you can blink. So to carry out this test, we start our engine, turn on your lights. The headlights are on as well to put a bit of load on the alternator, and we must increase the engine speed to about 2000 RPM. So there on the screen you can see the result. Okay, so you can see the voltage ripple. So I'm going to do it there now. I'm going to see if I can pause this. So I'll just turn off my engine for a second, and we go over and we evaluate what it looks like. Okay, so basically here's our ripple voltage. Okay, that's our AC ripple, and as you can see, it's quite uniform. Alright, don't worry too much that it goes up and comes back down again. That's actually okay. Alright, but the ripple effect is uniform all the way along. That's what you actually want to see. Alright, and if we have to measure from top to bottom here, it's a lot less than a half a volt. Okay, so we're looking there maybe about just over 0.1 of a volt is our 100 millivolts, that would be, is our voltage ripple, which is perfect. Okay, again, if there was any defects here, what you would see is little problems like this occurring all the way along our image, and that would suggest faulty diode or faulty stator winding.